No, that's not my cell phone. It's the sound of outer space, kind of. It's a radio signal picked up by one of NASA's radiation storm belt probes. These probes are orbiting inside Earth's radiation belts, a hazardous part of space filled with high energy particles, and these eerie chirping noises are called chorus. Scientists have known about them for years. Ham radio operators have listened to them, but these are the clearest recordings yet. Here to tell us more about these chorus recordings is Craig Kletzing. He's the F. Wendell Miller Professor of Physics and Astronomy at the University of Iowa. He's also the principal investigator for one of the experiments on the radiation storm belt probes. Dr. Kletzing is joining us today from Iowa City. Welcome to the program.
Thanks for having me.
So let me just start with, what did we just hear? Explain it for us.
So what you're hearing is a measurement that we make on our new mission. We just launched the radiation belt storm probes back in the very end of August, and we make measurements of the radio waves, and it turns out that these radio waves are in the same frequency range as human hearing. So we can take our measurement, we just turn it into a WAV file or an MP3 file, and then you can listen to it.
Wow. And you have some other sounds as well, right? I think we have one ready to go. What's that one?
That's a very classic sound for people in our field. That's something called a whistler, and it's been known for a very, very long time. And it comes about when a lightning strike occurs on the surface of the Earth, and that sends out a whole broad range of various radio waves, and they go up, and some of them can make it out through the Earth's ionosphere, which tends to reflect a lot of it. And as they move along out into space, it turns out the higher frequencies, the treble pitches, move faster than the slower, bassier pitches. And so when they get to our satellite and we measure them, what you hear first is that high-pitched, and then it sweeps downward to lower and lower and lower frequency.
I'm Flora Lichtman. This is Science Friday from NPR. Map out where these probes are picking up these sounds for us. Give me some basic landmarks, like let's take the International Space Station and maybe the moon. Where are these belts in relation?
Okay. Well, the space station is in what we would call a low Earth orbit. And so the closest that our probes come in, which we call perigee, the lowest spot in the orbit, is a little bit outside of where the space station is. We come into about 400 miles or so, and I think the space station is around 200, 250, something like that. Now, we go quite a ways out. We go out to about 35,000 miles or so.
And it's...
but the moon is way beyond that.
Right. So this is a kind of dangerous part of space, right?
Well, what we're flying in are what people call the Van Allen radiation belts. Have to get a plug-in for Iowa there, since Van Allen was from the University of Iowa. And this is a region of sort of donut-shaped, very energetic particles which surrounds our planet. There's actually two of them, sort of these rings around us, that are very high-energy particles, and when they're that high energy, we call them radiation. And this is this radiation can damage satellites or be unhealthy for astronauts. And so it's a region that most satellites try to avoid or spend as little time in as possible. But we want to understand how they work better, so we had to build something that could go there and live there.
And this transfer of energy in these belts is actually what's causing the noise, right?
Exactly so. It's quite an interesting process. The waves are kind of like almost like a catalyst or a carrier of the energy. So they come about out of lower energy electrons, we know, and they grow up, and then they give their energy up as they fade away into higher energy electrons, which become the energetic particles that we call the radiation belts. So they kind of are a transport mechanism, if you will, from low energy to high energy, and thereby help create the radiation belts.
And where does the energy come from in the first place that feeds these belts?
Well, the overall energy source for all of this is that big ball we see every day, the sun.
Oh, that thing.
Yeah, that thing. But the sun is moderately variable, and every now and then it'll send out an extra strong stream of particles that we call the solar wind. And that when that comes along and encounters our planet, we have a magnetic field, and so that acts as sort of a barrier, but it still puts energy in. And when all that energy comes in, it goes into these particles, and then This is one of the mechanisms whereby things get transferred into the very high energy particles that make the radiation belts.
I heard that the Van Allen belts were discovered accidentally. Is that a myth or reality?
Well, I wouldn't say exactly accidentally. I mean, the story, of course, is that back in 1958, Sputnik had gone up, and the U.S. was sort of, oh my goodness, how could the Russians get into space before us? And so very rapidly, we started looking around. The U.S. wanted to find something they could put up, and Van Allen at that time had been flying a series of rockets that actually went up on balloons first and then would go off. They were called raccoons. And so he had the kind of hardware that you would need that could make a measurement. And so he teamed up with Pickering and von Braun, and they launched Explorer 1. And sort of the accidental part of this was so what they expected to see were just cosmic rays, which are a fairly low level of intensity, and you would just sort of see some counts as you went along in his detector. What they found instead was as this thing was orbiting around the Earth, suddenly the count rate started to climb, and then it went to zero.
And that's the famous quote, space is radioactive, right?
Yep, and then suddenly it came back, and then it went back down, and they scratched their heads for quite a while. And finally what they realized is that there was so much radiation there that it was doing what's called saturating the detector, so it just couldn't count anymore. It was just overwhelmed. And then when it would go out of the radiation belt, it would come back down to a reasonable level that it was designed for, and it would start counting again. And so it took them a little while to figure that out. But once they did, that was the discovery of the radiation belts.
And now we have the probes to follow up. Thanks, Craig Kletzing, for joining us today.
You're very welcome. Thanks for having me.
Craig Kletzing is a professor of physics and astronomy at the University of Iowa.